Why does time dilate near massive objects? Imagine you are floating in space, looking at a star or a black hole, and suddenly you notice that time seems to move differently depending on where you are. This strange idea is called time dilation, and it happens because of how gravity influences time itself. You might think of gravity as just the force that pulls objects toward each other, but in reality, gravity is more like a bend or curve in the fabric of space and time. Think of spacetime as a giant trampoline. When you put a heavy ball on it, the trampoline dips down. Smaller balls will roll toward the heavy ball because of the dip. The more massive the object, the deeper the dip in this fabric. Now, because of this curvature, time doesn't flow the same everywhere. Near a very massive object like a star or a black hole, the curvature is much stronger. This causes time to slow down compared to places where gravity is weaker. For example, if you had a clock on the surface of the Earth and another clock for away in space, the clock on Earth would tick just a tiny bit slower. This effect is called gravitational time dilation. It might seem small, but it has been measured and confirmed through experiments. For instance, satellites orbiting the Earth experience weaker gravity than on the ground, so their clocks run slightly faster. To keep GPS systems accurate, scientists have to adjust for this tiny difference. The effect becomes even more noticeable near black holes. As you get closer to the black hole's event horizon, the point of no return, time appears to slow down more and more from the perspective of someone far away. To an outside observer, it would seem like time almost stops for anything near the black hole. This is because the gravity is so intense that it warps spacetime to an extreme degree. So, in simple terms, time dilates near massive objects because gravity bends spacetime, and this bending causes time to pass at different rates depending on how strong the gravitational pull is. It's a fascinating part of how our universe works, showing us that time is not a fixed clock but something that can stretch and slow down depending on where you are in the universe.